Since you already have experience graphing your own rational functions, we are going to work backwards today. We will write equations given characteristics or given a graph, and from the graph you can identify the characteristics. So here's a list of characteristics on the left. We know we're writing a rational function. We also know that a vertical asymptote is always represented by a factor in the denominator. A zero of the function is always represented by a factor in the numerator. So we've taken care of those two characteristics. The last one, horizontal asymptote, is just a minor adjustment that I saved for the last step. Right now my horizontal asymptote is x divided by x, which is 1, so y equals 1. We want it to be y equals -2. We can make that happen by adjusting our equation with a coefficient. You can leave your equation factored like this, or if you feel like distributing, you can. That is our first rational function. Let's look at the one on the right. The vertical asymptote will be represented by a factor in the denominator. This one has a hole in the graph, and that is always represented by matching factors in the numerator and denominator. Also the zero of the function, which I could have done before the hole in the graph, it wouldn't matter. It's always represented by a factor in the numerator. And again, leaving horizontal asymptote for the last step. Right now, x times x is x squared divided by x squared. Our horizontal asymptote right now is y equals 1. We don't want a horizontal asymptote, which means there would be a slant asymptote. And in that case, we have to have an extra factor in the numerator, an extra factor of your choice, so that there would be a slant asymptote. That would also give us an additional zero of the function, but that's okay. And I'm just going to leave this function factored. No reason spending time multiplying it out. Ta-da!